Carbon has two isotopes, 12 and 14. 14 is radioactive. The proportion of two isotopes in living things remain constant while they are alive. But when they die, the proportion of carbon-14 drops as the isotope decays. Archaeologists studying a bone find it emits 20 counts per second, whereas a similar modern bone emits 80 counts per second. The half-life of carbon-14 is 5,700 years. Use this to estimate the age of the bone that the archaeologists found. This is known as carbon dating. Through this method, we can find out how old the specimen is. For example, you would have seen that if some skeleton is found, some bones are found, then the archaeologists are able to estimate that how old this specimen is. So basically what happens that this carbon-14 is absorbed in the living organisms when they eat plants and other grass and such kinds of plants. So it goes into their bodies. Those animals sometimes are eaten by carnivorous animals. So basically this carbon-14 is present in all the animals. Definitely if this carbon-14 is a radioactive isotope, it is going to keep on decaying after a certain time period, after every half-life, so it is going to produce some counts per second. So they say that when a person is alive, for that person we would have 80 counts per second. And for example, a bone is found that emits 20 counts per second. Half-life of carbon is 5,700 years. So how can we estimate the age of the bone?
If the half-life is 57,000, you add another 57,000, right?
5,700.
5,700, sorry.
Yes. So after first half-life, the count rate is also, remember that just like the number of atoms decay, the count rate also decay in the same pattern. Okay, the graph for number of atoms decaying was like this. So if I took the time on x-axis and number of atoms, undecayed atoms on y-axis, so same is the case for count rate. Okay, if I'm going to plot the count rate and time on x-axis, the pattern would be the same exactly like this. So just like that, number of atoms decay half after first half-life, so the count rate also decreases by half after first half-life. So after first half-life, it would be 40. Initially it was 80. Went from here to here, 5,700 years have been passed. Then from half of 40 would be 20. Then again another 5,700 years would pass. So it means the age of the specimen is 2 times this.
Yeah.
1,400 years.